Welcome to this short video meant to show you how to get the most out of your calculator. This is frequently a tool that is new to a lot of chemistry students, particularly a scientific calculator, and it's got a few things that make it more useful for a scientist, and also a few potential pitfalls. A calculator, after all, is a machine. It's kind of by its very nature a little dumb. It only does what you tell it to do. So we want to make sure we can speak its language. For example, we might use a calculator to take a long set of conversion factors like this and evaluate it, get the final answer. And it's very easy if you're caught up in parentheses and trying to duplicate everything you see here on this screen. It's easy to actually wind up with a completely different answer than the one you intend. So for this problem, we're trying to figure out how many centimeters there are in an inch. We're assuming we're in a world where we weren't taught that on the first day, and we're using other conversion factors that we might know in order to come up with it. And so here we've got a whole list of them, 5 conversion factors, and I want to first impress upon you that multiplication and division are commutative. You can move the factors around without actually changing the answer you get, because at the end of the day, everything multiplies, everything divides, the order doesn't actually matter. And so my preference in a situation like this, and one I think will make your life a little easier, is that I just go through and I multiply everything that's on the top, and then I turn around and divide by everything that's here on the bottom. And you can skip over ones because clearly those aren't going to change anything. So in this case, I'm starting with my 1.00 inches, and I start by multiplying these 3 factors right here. 1.609, whoops, multiplying is a good idea, then times the 1,000, and then times 100. Once I've done that, I turn around and I do any division that's necessary here, and so I'm dividing by 12 and by 5280. Now to do that, I could put things in parentheses, I could try to multiply all those things together and then divide by it, but that's likely to confuse me more than anything else. It's actually very simple if I just simply say divide by 12, and then divide by 5280. And when I do all that, what I come out with, admittedly, is a very long number. It includes every decimal place that it's capable of calculating, but in essence what I have here is the 2.54 centimeters that we're usually comfortable with. Now, if you do have addition and subtraction mixed in with all this, as you might if, for instance, you were doing a problem like this, where you are calculating, let's say, a percent error. In this case, you do actually have to do these things in the right order. You need to simplify that before you can do the rest of it. And so my recommendation would be to do precisely that. Rather than monkey around with parentheses, try this. You've got that, and so you rewrite the whole thing. 1.1 now is what that has collapsed to, over 19.1 times 100%. And so at this point now you can do the rest of it. The 1.1, which is stored right now as answer in your calculator's memory, is divided by 19.1 and then multiplied by 100. And so there you have it. You've now got 5 and it's again 5.75991, etc. Lots of digits. Bear in mind in this case that because this is just 1.1, this is going to really be 5.8%. If we're treating the 100 as an exact number, that actually limits it. When you do have these guys happening at the same time, a little bit of addition and subtraction and some division or some multiplication all together, you need to make sure you're evaluating your sig figs every step of the way. All right, now the other big thing that the calculator will help you with is dealing with scientific notation. And so, for example, if I've got a number like 4.8 times 10 to the 4th, it's very tempting to look at my calculator and assume that I just need to write that like this, 4.8 times 10 to the 4th. And certainly if I do that, it will give me what I want. It will give me 48,000, which is what that number equals. The problem is, this is a whole lot of math. You're making the calculator actually do that math. Let's say that that number was in the bottom of a conversion factor. If you told the calculator to divide by 4.8 times 10 to the 4th, the calculator would understand that you were dividing by the 4.8, but then it would be multiplying the whole thing by 10 to the 4th, even though that 10 to the 4th is in your denominator. And so One option is that you write them this way and you put them in parentheses. That is a little suboptimal as far as I'm concerned. And so what we're going to do here is take advantage of this being a scientific calculator and the fact that it has a mode for scientific notation. And so what you'll find is that there's a button on your calculator, something like this. You'll see this EE here. That's what it is on this calculator. In some cases it's EXP. In others it will actually be times 10 to the Y or something like that. But I encourage you to look for those buttons and use them in this situation. In our case it's EE. It's a second function, so what I'll actually have to do is hit second and that button in order to accomplish what I want. But here's how this will work instead. 4.8 E4. And notice that it gives me the same thing. The difference is that is now 1 unit. The calculator understands that as just being a single number all slapped together. In fact, if I'd like to see it in scientific notation, the calculator has a way of doing that too. You'll see up here, there's this little sci/eng second function. That is there to allow you to flip between modes. What we're doing right now, where it just shows you the normal number, is called floating point. But if I go into this mode menu, I have floating point, I have scientific, I have engineering. What I'm interested in is scientific. So I'm going to come over here and do that. And now you'll notice that it shows me 4.4 times 10 to the fourth. So the key thing to bear in mind is that's what the E actually stands in for. Whenever you hit that button, you want to say to yourself, times 10 to the. So 4.8 times 10 to the fourth. If I want something smaller than 1, 2.58 times 10 to the negative 10, for example. You can throw that in. Now, one thing just to be aware of, if you do actually have something that is a bare power of 10, let's say 10 to the minus 14, which you will encounter later on when we're doing acid-base work. 10 to the minus 14, if I just write in 10 E minus 14, it's tempting to think that's right. But let's review what the E means. What you've really written here is actually 10 times 10 to the minus 14, not just strictly 10 to the minus 14. And so when I do this, you'll notice I don't actually get 1 times 10 to the minus 14. I get 1 times 10 to the minus 13. So if I want to do this, I want to remember that a bare power of 10 is the same thing as just 1 times that power of 10. So if I want to put that in, that's just going to be 1 E minus 14. 1 times 10 to the minus 14. Now, last but not least, now that we can do scientific notation, we're going to play around with a few calculations and look at mainly the limitations that a calculator has in terms of sig figs. Calculator doesn't know anything about this, so whenever you're doing a calculation in the sciences, you are doing 2 calculations. You're finding out the number, and you're also figuring out how certain you are of that number. And so, for instance, if I have a calculation like this, 5.0 times 10 to the minus 4 over 3.6 times 10 to the, well, let's make it minus 2, why not? When I do this, I'm going to type in 5.00 times 10 to the minus 4, and then divide by, and notice I don't need to use parentheses or anything because the calculator understands this next thing as all being one number. 3.6 times 10 to the minus 2. When I pump this through, I get the correct answer. You'll also notice I get a whole boatload of extra digits. The calculator is going to show me everything it can get. I need to do the rounding to come up with the correct answer. So since I've got 2 sig figs here and 3 here, and it's just a division problem, I'm going to need to limit it to 2 digits. So it's going to be that 10th place right there in my scientific notation. I'm going to round it up because of the 8 that comes after it, and end up with 1.4 times 10 to the minus 2. Now this can cut both ways. Sometimes there are a whole lot of extra digits that are going to be shown after the fact because the 2 numbers don't go evenly into each other. In other cases, such as the one I'm going to do right now, in these cases, sometimes the numbers go too perfectly into each other. If I type this in, 3.86 times 10 to the third, divided by 1.93 times 10 to the negative 7, what I wind up with here is actually 2 times 10 to the 10 because it turns out this is exactly twice that. However, we're scientists, we still need to quote our number with the right amount of uncertainty, and so since I have 3 digits in each of these, what I'm going to need to do is write this number as 2.00 times 10 to the 10th. Remember that the calculator does not actually calculate sig figs for you. That is something you have to do. Believe it or not, in that venue, you are smarter than your calculator. Now, if you're unsure of where any of these buttons are actually located, in particular the mode switch button that we worked with here, or the exponential, the scientific notation times 10 to the button that we worked with in the earlier problems, don't hesitate to see your tutor or to talk to your professor about where those buttons are located on your specific calculator. They'll make your life a lot easier, and we wish you a happy semester of getting all the answers you intend to out of your scientific calculator.